Notes Part 4. This is going to be about diffraction and interference. First, we need to define diffraction. Diffraction is the bending of a wave as it passes by an edge or through an opening. So the amount of diffraction increases as the wavelength increases. So have you ever noticed how you can hear someone around a corner before you can see them? That is because of diffraction. Interference occurs when two or more waves meet while traveling in the same medium. Remember, medium would be like a solid, liquid, or a gas, and these waves actually overlap. The amplitude of the resulting waves is always the sum of the amplitudes, and this interaction can be constructive or destructive, and we're going to talk more about what those terms mean. In constructive interference, we result in larger amplitudes, which means our crests and troughs are higher away from that middle point. And when crests and troughs overlap, we can see that the amplitude is higher. So in this red and blue wave, you can see that they're going to interact. And when they interact, it creates that new green wave, which is twice as tall, or is the addition of the red and blue wave. And so that crest is taller. In the troughs, you can see the red and blue waves as well, and you can see that their amplitudes has also increased to the red plus blue, which equals green. Here are some great pictures of constructive interference. We can see these being added together so that the amplitudes are the two amplitudes added together. Complete interference is when the first crest lines up with the second wave crest in constructive interference, or the crest lines up with the troughs, and in that case it would be destructive interference. So in the top picture you can see that the combined waveforms of wave 1 and wave 2, the crests and troughs match up, and so therefore we have constructive interference. However, in the bottom photo, you can see that the crests and troughs are opposite of each other. And because the crests and troughs are opposite each other, when they combine into one wave, it leads to a straight line, which is destructive interference. Incomplete interference, though, is when the crests and troughs do not completely line up. And incomplete interference can be constructive or destructive. You can see in this picture in the bottom right that these crests and troughs do not exactly match up, and therefore in this case we have incomplete interference. Destructive interference is when crests and troughs overlap. So the crest matches up with the trough and the trough matches up with the crest perfectly, and this results in a smaller amplitude because essentially they are canceled out. So that crest can cancel out the trough and the resulting amplitude is reduced. And we can see that in this example here. In the top one, you can see that before and after interference that we are left with a green wave, that because the blue wave has a higher amplitude, the green resulting wave is closer to the blue wave. But then in the bottom example, you can see that this red and blue wave have the exact same amplitudes, they're just opposite, and therefore their interference will result in a straight line. So here's a great example of destructive interference. Here's another picture of our constructive interference versus our destructive interference. So, as a reminder, as we review our reflection, refraction, and diffraction, reflection is when waves bend, the way that waves bend when it bounces back off the surface of another medium. Diffraction is the wave bending around an edge, and refraction is wave bending when it enters a new medium and therefore changes speed. So these are the important things that we have learned throughout our wave notes.